Okay, let's take a look at our handout for Chapter 3, Describing Data. We start with a quick review of the formulas that we've been using. The mean is simply the sum of the x's, that's sigma x over n, where n is the number of x's and sigma x is the sum of the x's. The median is the middle value when the data is arranged in order. The mode is the value which occurs most often, or those values which occur most often. The mean from a frequency distribution means that we have to multiply those x's times their frequencies f. I put that in parentheses. You don't have to put it in parentheses. That multiplication happens before the sum. Remember, that's part of the order of operations, over the sum of the frequencies. Now you might say, isn't that the same as a weighted mean, where instead of an f we've got a w? And you're exactly right. So when you look at the next formula for a weighted mean, you can see that x bar is the sum of the f's in the denominator, and in the numerator the sum of the x times f's. So f is our weight. So you can think of that as exactly the same formula. And of course the range is the largest value minus the smallest value. So let's take a look at our first example. It asks us to find the mean, the mode, and the median for the following numbers. So the mean asks you to add them all up and then divide by their number. So when I added them up, I got 483. It counted 15. So when I divided by 15, I got 32.2. The mode is the value that occurs most often. And here we can see those 3 9s in a row. There are no other numbers that appear more than once. So our mode is 9. And the median, when you cross them out from the outside to the inside, you're left right there at the middle with 21. Let's take a look at an example with a frequency table. So the first thing that we do is, if we were adding these up, in that first row it says that there are 2 6's. Well, that's the same as saying 6 plus 6, but repeated addition of the same number is multiplication, so we're simply going to multiply. 6 times 2 is 12. That's the same as 6 plus 6. Again, in the next row, it looks like we've got 3 10s. 10 plus 10 plus 10 is 30, the same as multiplication. We're just multiplying across. So we get a 30, and we continue in that way to get our products. Now the frequency column is going to get added up, as is the x's times the f's. And we can use our formula. We now have both sums. So in the numerator, the sum of the x times f's. In the denominator, the sum of the f's. And we do that arithmetic. The mode is simple from a frequency table. We simply look at it and see that there are 8, and no more of anything else, 8 14s. So the mode is 14. Now let's take a look at the standard deviation. So we're going to start with 2 examples that hopefully will convince you that the standard deviation behaves the way you expect it to. So here's our formulas, reminders of that. Let's look at example 3. It says find the standard deviation of the following data. And the data row shows us 10, a 10, and a third 10. So we've got 3 10s. Now remember, the standard deviation is kind of the average unaverageness. In other words, how far that data is from the mean. So the first thing we need to do is compute the mean. Well, that's relatively simple. None of these numbers differ from each other. The mean is 10. You can go through and do the arithmetic as well. 10 plus 10 plus 10 is 30. 30 divided by 3 is 10. Now, the deviations are how far that data point is from the mean. Well, these are all identical to the mean. There is no deviation. And similarly, when we square 0, we get 0. You add up a whole bunch of zeros, and you've still got 0. That's the sum of the deviations squared. So that's our numerator. So when we go down into the radical, our numerator is 0. Then remember, our denominator for standard deviation is 1 less than n, so we're dividing by 2. So, well, anything divided by, anytime you divide 0 by anything, you're going to get 0. So the square root of 0 will give us 0. There is no standard deviation. All this data is clumped right there at the mean. Let's look at the next example. It says to find the Standard deviation again, but now we're looking at 3 values, 5, 10, and 15. You can quickly convince yourself that 5 is as far below 10 as 15 is above 10. The mean is still 10. Now, you might also think to yourself, well, it looks like the average distance or deviation from the mean is 5. And for straightforward examples like this, I think you'll see that that works out perfectly. So the first thing we need is the deviation. 5 is 5 less than our mean of 10. 10 is exactly the mean, and 15 is 5 more. So we have -5 for the first deviation, 0, and then 5. We square those. A negative squared is a positive, because negatives times negatives are positives. 0 times 0 is itself 0. 5 squared is 25. We add them up. 2 25s is a 50. Remember, that will be our numerator. In the denominator, we'll have 1 less than n, or 2. 2 goes into 50 25 times. The square root of 25 is 5. Exactly what you'd think. Our next example is not something that I can look at and see what the standard deviation will be. So let's work through this. The data is 2, 7, and 21. So we add those up and divide by 3, and we get a mean of 10. So 2 and 7 is 9, 9 and 21 is 30, 30 divided by 3 is 10. Standard deviation is still 10. 2 is 8 less than our mean. 7 is 3 less than our mean, and 21 is 11 more than the mean. So there's our deviations. We're now going to go through and square those. -8 squared, -3 squared, and 11 squared. That gives us 64, 9, and 121. We add those up. That's our new numerator. Remember, we're dividing by 1 less than n. That gives us 2. When we do that division, we find that we're taking the square root of 97, which in our calculator, notice that 5 in the 5th decimal place over tells us to round the 8 up. So if we're rounding this to 4 decimal places, we'd say 9.8489. One more example, and I think we'll have seen why it's nice to use our calculator. The first thing we have to do here is find the mean, and in many ways that's the most single arithmetically challenging part. So we add up all these numbers, and we can see the numbers in that top row, that data row. So we add them all up, we get 45. We count how many there are. There are 9, so we divide 45 by 9. Our mean is 5. So then we figure out how far these data points are from the mean. 1 is 4 less than 5. 3 is 2 less than 5. 8 is 3 more than 5. 4 is 1 less than 5. 6 is 1 more than 5. 4 again, 1 less than 5. 3, 2 less than 5, you get the idea. 9, 4 more than 5, and 7, 2 more than 5. We take those deviations and square them. So notice everything is now positive, and we add up those squares. That's going to be our numerator, 56, and we're going to divide that by 1 less than n being 9. So we go through and we do the arithmetic, and we learn that 8 goes into 56 7 times, and that the square root of 7, well, we have that issue with rounding to 4 decimal places again because of that 5 in the 5th place. So we round this approximately to 2.6458.